All right, guys, let's look at the warm-up. Okay, so converting to polar on this first one. Everybody okay with r equals 2? Good with that? Okay. Then what you're thinking about is tangent of theta equals 1 over negative root 3. So really, tangent of theta equals negative root 3 over 3. And this is where you want to sketch and remind yourself, okay, that was a second quadrant point. So if I start with a positive radius of 2, what is the theta that gets me in the second quadrant that is the root 3 over 3? Sydney, what do you think? Yes. Okay. Lots of options for other answers you could give me. If I stuck with positive 2, what'd you guys say? Did you give me a negative angle? Yeah, Karen. Okay, so if we had positive 2 again, what's another angle that could go to Libby? Negative 7 pi over 6. I like that. Okay, then I'm going to switch and do a negative 2. I think the negative angle is actually easier on this one. What would that be?
It would be negative 5 over 6.
Good.
But, like, I did have a question. So
oh, yeah. You're like, I don't want to just answer.
Yeah, but I had put, like, 11 pi over 6, but I'm realizing, like, would that not be right since that's not going with, like, the triangle that we have to set up?
Yeah, that would not be where this point
Even though,
is.
like, tangent to negative 3, well, negative root 3 over 3 could be half, like, that.
Yeah, that's why I always say with these, sketch the dot, just so you have it in your head, like, oh, this is where I am. Because you could do negative 2, negative 11 pi over 6.
Oh, yeah.
Or positive, sorry, not negative. That's the one that's not negative. But if you have a positive 2, 11 pi over 6 doesn't work. Question, Karen?
So how is the variance between 2 and negative 2 vary?
No, because negative 2 would mean start over here and then travel around 5 pi over 6. That would be that. Okay? It's giving you a different starting point, and then you start your angle counting from that. Okay? All right, we okay on number 1? Number 2, converting to rectangular. Remember, this is where for x, we just do r cosine theta. So 4 cosine of negative 3 pi over 4. Well, what is the cosine of negative 3 pi over 4? Yeah, negative root 2 over 2. So this is negative 2 root 2. Okay with that? What about the y? Is it going to be any different? No, it's the same thing because that's the third quadrant angle. So that is your answer. Negative 2 root 2, negative 2 root 2. A lot of 2's. A whole bunch. Okay, so points we're okay with? Okay, let's look at our equations then. Okay, for number 3, this is one where I think it's easier if you multiply it out before you do your substitutions. This would just be x squared plus 2x plus 1 plus y squared minus 6y plus 9. What is, well, I'll just rewrite it. We've got x squared plus y squared. I'm putting those together. Then I have plus 2x minus 6y. What happens to the 1, the 9, and the 10? Yeah, they're just gone, so I got a 0 over there. And then I can substitute. X squared plus y squared is r squared. 2x would be 2r cosine theta. Minus 6y would be minus 6r sine of theta. Now, he didn't say solve for r, so what do I have to do at this point? Yeah, factor in r out. And I'm left with r plus 2 cosine theta minus 6 sine theta equals 0. When I set the two factors equal to 0, I get r equals 0. And are we okay with the other one would be 6 sine theta minus 2 cosine theta?
So I did like that, but then instead of factoring, I had like added the sign and divided by cosine first to cancel. But I guess when you cancel out like any r's, you like lose cancel, right?
Yes. And what do you mean you divided by cosine?
Well, I meant I added 6r sine beta to the other side and then divided by 2r cosine beta.
So hold on. Let me just show it because there's an issue with that. So you were here, right?
Yes.
If you divide,
Wait, why did I do
do you see why it doesn't work? Because you'd also have to divide this by
Wait.
cosine.
that? Yeah.
Don't
That
do
made
it.
sense. Okay, there we go.
Don't do it. Okay.
I was almost there.
Yes, Karen.
So would it still be okay if I did conversation where I multiply it for
Did you get to the same answer? Yeah. You just have to, it's just uglier multiplication. But yes, you can absolutely stick it there. All right, number 4. Do you guys recognize it's a circle right away? Yeah, and we have to multiply by r? Yeah. Okay. So multiply by r, I get r squared equals negative 3r cosine theta. X squared plus y squared equals negative 3x. Bring that over. Leave some space because what do we get to do? Everybody's favorite thing. Complete the square, yes. So the 3, I divide it by 2, and I square it. What is 3/2 squared? Not a decimal, guys. 9/4. Do not give me decimals when you're doing this. All right. Make sure you add your 9/4 to both sides. What is this parentheses squared going to end up being? It's x. And why'd you say minus?
I don't know.
Okay. It's x because that's, in our notes we did y. This one is x. Whatever this sign is in front of that b value, that's the sign that's going to be in your parentheses. Okay. The 3/2 is right. And then we have plus y squared equals 9/4. What this means then is this is a circle with a center at negative 3/2, 0, and a radius of 3/2. Today you're going to learn how to just look at that equation and graph it as a circle. So you could also just write the equation of the circle from there without having to do all of that. Okay? Because it's x plus 3/2, it's always the opposite. The general form for a circle is x minus h quantity squared plus y minus k squared equals r squared. So it's always going to be the opposite here. Get in the habit of just doing fractions because it's going to make everything easier when we're squaring and square rooting. Yeah, go ahead. And it's more exact because if it's not, like if it's 1/3, I don't want you to tell me 1/3. Okay.
So like for this, what was I gonna say? Oh yeah, no, when it's like on the test, when it's like asking for that, would it be like convert and then like say like the center point and like the radius?
Yeah, it all depends on how the question's written.
Okay.
Yeah.
Wouldn't the radius be 9/4?
No, because that's the radius squared.
Okay.
It's like here's your general form of a circle. It's always r squared.
No.
Yeah. Other questions, guys? Good questions. Okay. Homework. So, just so you guys are aware, on Schoology, under materials, just so you know where it is, Unit 8. At the bottom here, there's Unit 8 worksheet keys. So guys, this is there for you to check this, okay? The homework for this unit, like Obviously, it's not there for you to copy it. That's not going to help you prepare in any way for this unit, but it is there for you to check so you can make sure you're on the right track. I know there's a couple of mistakes on this key, but let's look at it. We'll start at the top here. Any questions on the graph or question 2? Yeah. Either one of you, Caitlin or Kevin. Oh, to radians? Yeah, so it's fine if you did that. General rule, if I give you the angle in degrees, I'd like your answer in degrees. If I give it to you in radians, I'd like your answer in radians. Okay. I agree that radians are much easier to work with than the degrees, but another question here. Here?
Could we employ negative signs? Oh, sorry.
What, are you good? Okay. Troubles anywhere, guys? Or if you can't read something, let me know. Yeah.
So what's the answer to one?
What's the answer to what?
What's the answer to
1C for D? I don't know what that means. 1C for the radius. Are you talking this right here? This one? The radius, -3?
the radius?
Oh, 5 pi over 6? Yeah? Okay. Sorry, I just wanted to make sure. I was like, I don't know what you're asking. All right, guys, I'm going to scroll down. And I know there's some mistakes here, so hold on. Let's see. This number 4b, it should equal 1, not 0 over here. And 5a, when you're solving, that needs a square root in there for the denominator. Yeah, Kevin? 4b, yes. Are you talking 5b? Okay, I thought you said 4b. I was like, there's no 4 in. Yes, this is actually where you probably should go. I don't think I said solve for r in this, though. But if you solve for r, that's where we should end up. And you should also have the r equals 0. Yeah.
So we look for the negative negative 2, negative 5.
Okay, which one?
3b.
3b. So you said what, negative pi over 6?
Negative 2 pi over 6.
Negative 2 positive pi over 6? Yes, that would also be correct. No? For 3b. So this point right here, do you see how that would be a third quadrant point? And if you did negative 2, so start over here and then went 7 pi over 6, you'd be in the first quadrant. Okay. Kevin? No. It's okay. You can always do more work for me. Just don't mess it up. All right, guys, any other questions? We got to make sure we get through notes today. We only have half an hour left. Actually, less than that. Brandon, you okay?
Yep.
Okay. All right. So for future reference, guys, you can always check your homework before you come in, and then let me know what questions you have. Bless you. All right, guys, find this page in your packet. We're graphing lines and circles today on the polar coordinate system. So last time you were missing lines from your grid. Now you've got bonus lines in your grid. Okay. Like this is 0, this is pi over 2 at the top. Pi over 4 has a line today. The pi over 6 and pi over 3 are right next to that. You've got bonus pi over 12 lines on this one. Okay.
Yeah.
Look at that. Lucky you. All right, guys, the first one here, theta equals pi over 4. We talked about this in like the last example or last practice problem last class, what this looks like, but let's think about plugging in some points and graphing it. So if I told you, like, let's say the radius is 2, what is the theta in this equation? Do not overthink this. Yes. What if the radius is 4? What's theta? Yes. What if the radius is -2? What's theta? Okay, and one more. What if the radius is 0? What's theta? Okay. A lot of pi over 4s. If I actually go to plot those points, so I can go to a radius of 2 and then come around to pi over 4. Put a dot. Radius of 4, angle pi over 4. -2 pi over 4. 0 pi over 4. What do you see those dots creating? A line. Yes, this is the equation of a line. So you can connect those. And what angle do they follow? Pi over 4, right? It says theta equals pi over 4. So anytime you see theta equals some angle, that's just the equation of the line following that angle. You can also think about it in terms of slope. The slope of this line is always equal to tangent of the angle. So tangent of pi over 4 is 1. That is a slope that goes through, or I'm sorry, a line that goes through the pole or the origin with a slope of 1. Okay. So if you had to convert it to rectangular, hopefully you could look at that and just go, oh, that's y equals x. A big part of this unit at the end is just being able to look at the equation and recognize what the graph is. Okay, you're not going to be making a little r theta chart every time for these. You're going to look at that equation and go, oh, that's a line, and be able to graph it. Okay. All right, the next one, we've got r cosine theta equals -3. Well, what is r cosine theta? X, okay. We're going to keep that in our brain here for a second. Let's plug in a few values just so we can plot this. If I solve this for r, do you see how it'd be -3 over cosine theta? Okay, we're going to plug in a few thetas, not very many, just so you can see that this is actually also an equation of a line. What if theta is 0? What is the cosine of 0? Just anybody say it. 1, -3 over 1, we'd get -3. I could plug in pi over 6 or pi over 4, but with cosine, that's going to give me kind of ugly numbers, fractions and radicals that I don't really want to plot. So I'm going to go to pi over 3. What is the cosine of pi over 3? 1/2. So this is, what's negative 3 divided by 1/2? Negative 6. Okay. Because you're dividing by the negative 1/2. Yep. All right. Let's plug in, I don't know, let's do negative pi over 3. What do I get for my r there? What? Not positive 6. What is the cosine of negative pi over 3? Positive 1/2. So what's negative 3 divided by positive 1/2? Also negative 6. Okay, let's try to plot these 3 points, and then we'll also look at x equals negative 3. So radius of negative 3, theta of 0, that's just 1, 2, 3. There's your dot. All right, negative 6, positive pi over 3. So negative 6 is out here. And then from that starting point, I'm traveling around to pi over 3, which is right down there. Then if I do negative 6, negative pi over 3, again, starting at that x, traveling backwards that same amount. Do we see how it's a line? Just a little vertical line over there? And isn't that what x equals negative 3 would be? Just a vertical line at x equals negative 3?
Yeah.
Again, you're not going to have to plot, make the little chart here with all of this. It's just to help you see that, yes, that's actually accurate. So when you see r cosine theta, you know it's a vertical line at whatever it equals. Yeah, kind of wild. So let's look at the last one. What is r sine of theta? Y. So this is the line y equals 2. How do I graph y equals 2? This way this time. X is this way, y is this way. So I'm just going to go to 2. It's kind of weird drawing a horizontal line through the circle, but you can do it. And that's it. And that's the amount of work you would have to show me. Karen. You'd get that, absolutely. I'd solve it for r. I'd do like 2 over sine theta. And then you can't plug in 0 because you'll get undefined at that point. But yeah, you can plug in all the others. Okay? All right, questions so far? We like lines? Okay, turn the page for me. Okay, this next one here, we've got r equals 5. So you probably already know what it is, but let's plug some angles in. What if theta is 0? What does r equal? Good. What if theta is pi over 2? What does r equal? What if theta is 11 pi over 6? What does r equal? I'm seeing a pattern, guys. What do you think this is? What shape is this? It's a circle, right? It says r equals 5. That means radius is 5 of your circle. So all you have to do is center a circle at a pole and then come out to 5. So anytime you just see r equals some number, you know it's a circle. Center at pole. And this one is radius equal to 5. So again, you would not actually fill in the chart. You'd just go, okay, here's my circle, and you're done. All right, then we've got r equals -2 cosine theta. Do you guys recognize that from converting? That'd be one where you multiply by r, completing the square. This is a circle. Okay. You do not have to do completing the square or anything like that to graph it. We're going to plot points for the first one so you can see like how it works, what the individual pieces tell us here. But then like on the next one, you should be able to graph it without plotting any, not plugging in any values, okay? So we'll plug in a few for this one. Let's say theta is 0. What's the cosine of 0?
1.
Times -2? Okay. Again, I'm picking specific thetas that are easy to plug in, so I'm going to pick pi over 3. Because what's the cosine of pi over 3? 1/2 times -2. -1. What about pi over 2? What's the cosine of pi over 2? I heard a lot of mumbles there. No? 0. Okay. All right. We can do this, guys. Okay. 2 pi over 3. What's the cosine of 2 pi over 3? Just anybody say it. What did you say? Sorry.
-1/2.
Yes, and -1/2 times -2. 1. Starting to worry about you guys. Okay, one more point. Let's do pi. What is the cosine of pi? -1 times -2. 2. Okay. Let's plot these. So -2, 0. That's just left 2, and then you don't go anywhere. -1 and then pi over 3. What quadrant is that in? Third. Okay, good. Just making sure we are getting our points okay. 0 pi over 2, that's just the pole. 1, 2 pi over 3. Everybody okay with that second quadrant? And then 2 pi, you're actually back to where you started. All right, 4 points. It doesn't really look like a circle there, but let me draw in my circle and see if you see it. You see how it actually lines up on the dots? 2 pi is over here on the left. Because I count out 2 and then travel around pi. It's the same as, these two are the same point. Okay, so this is a circle. What's the diameter of this circle? 2, okay. If we're thinking about it starting centered at the pole, where did this one shift? Up, down, left, or right? Left, okay. Shift left. So let's look at our equation and how do we just know all of that from this equation? So cosine. Does cosine tell me x or y? X. So we know wherever this is shifting, it's shifting on the x-axis. It was a negative out in front. So if you're going on the x-axis, your choice is left or right. Negative, so we know it's left. And then whatever that coefficient is, that is the diameter of your circle. So, oops, sorry. So let's try to graph r equals 4 sine of theta without plotting any points. I just want you to graph the circle. So you guys try it on your paper. Graph for me r equals 4 sine of theta, based on what we just looked at with that last one. Check with your neighbor. Do you guys agree? Did you draw the same circle? I know, I get a cheat and use the little circle drawing tool if you guys don't have that. And when I'm grading it, I'm not going to look at it and go, oh, that's not a perfect circle, you're wrong. But if you're drawing something that is like supposed to be a circle and you draw like that, like that's not a circle, guys, okay? I realize we are not all world-class artists, but you gotta be like close-ish, okay?
Like the points and like making letters to attach them.
Yes,
In not a.
it's okay. Yes, yes. So guys, r equals 4 sine theta. What does the 4 tell us? Diameter is 4. Is it on the x or y axis? Okay, up or down? Up. So it should look like, oh, not that. Hold on. That. Yes. Just like that, right? Not cheating at all. I know. Get the magic tool.
You just have to put down like the two, like the point at 4 and then the point at 0. You don't have to put down like any on the sides.
Nope.
Oh.
I don't really even care if you put any point as long as you draw the actual circle. Oh, okay, perfect.
Unless you really do, yes.
So, like, this is essentially going through 4, and this is going through the pole. Yeah. And then again, try to make it look like a circle. Try to not have it be some smooshed, I don't know, hamburger thing.
So will it always go through the pole?
Yes. So, guys, the graphs, you are graphing for circles. It won't go through the pole if it's just r equals. Ooh, that one got shifted off a little bit here. But all the others you're doing, they absolutely will, oh dear, will go through the pole, assuming I don't move them all. Okay, so you're going to be, a pole axis is going to be, you know, cutting it in half, symmetry there. That's what we're graphing. You can do polars that are like out here, but we're not going to do that. We are sticking with going through the pole. Okay. All right, so let's just fill in this top part on the next page. This is just sort of like your general rules, everything we've talked about, kind of putting it all together for you. So if r equals a, some value, I know that's a circle, center at the pole, and a radius equal to a. So that's like the first circle we drew. All right, if it's r equals a sine theta, again, I know that's a circle. I know the shift is on the y-axis this time. And I know the diameter is equal to a. If it's a cosine theta, again, circle. This time the shift would be on the x-axis. And again, the diameter would be equal to a. Usually when you look at diameters, you're not thinking of negatives. Yeah, so if you want to say absolute value of a, that's fine. All right, guys, if it's theta equals A, we know this is a line. And really what it's doing is a line that follows theta. Does that make sense? Like if it's pi over 6, you just draw pi over 6. You can also look at it as slope equals tangent of whatever that angle is. Okay, what if it's r sine theta? Is that vertical or horizontal line? Horizontal, good. So horizontal line at A. So our cosine theta would be a vertical line. All right, we've got a couple more graphs to get through here. First one here, r equals 5, but then I give you an interval. I say only graph it from 0 to pi. Maybe. So first, if it's just r equals 5, what is that the graph of? A circle, right, with a radius of 5. If I'm only graphing it from 0 to pi for my theta, though, what does that mean? Yeah, half circle, and are we okay with it be just the top? Start over here, radius of 5, and go from an angle of 0 all the way over here to pi. Ooh. I'm not going to use any special tool this time. So we do the horizontal line on the x-axis. What do you mean? No, because they wouldn't connect. Because if you're connecting them, you're implying that all of those points are on there. If you drew a circle with a radius of 5, there's no line through the middle of it, right? Okay. So this is your starting point over here on the right, and this is your ending point over on the left. Okay, the next one. R equals -5 on the interval 0 to pi. What does that look like? I see some of you going down here. That is absolutely right. Because if I start over here at -5, if that's my starting point, and then I'm traveling through 0 to pi, remember this is now 0. That's the starting point. So I'd be going here all the way back around. Hopefully you can draw on the lines better than I can. Does that make sense to everyone why it's the bottom half? Okay. 2 more, guys. This one we are not going to do the interval on. It doesn't work very well for what that actually is. Okay, r equals 4 cosecant. We've done nothing with cosecant. Yes, Gary.
Would it be 4 equals 1?
Yeah, because we're going to start with 4 cosecant of theta. What is cosecant of theta, guys? Yeah, so this is really 4 over sine of theta. Does that make sense? Okay. Do you see how we could multiply both sides by sine? And I would then have r sine of theta equals 4. Yeah, then that's y equals 4. So what does it look like? This, yeah. Hand signal. Horizontal line at 4. So I go up to 4, and then I just draw a line. It always feels weird to draw a straight line through all those circles. You okay with that one? Okay. All right. Last graph here. We're almost out of time. R equals -3 sine of theta. If you ignore the interval, what is that a graph of? Yes, a circle with a diameter of 3 shifted down. But we're only graphing it from pi over 2 to pi. So for these, you will want to do a little r theta t chart. So if I start at pi over 2, what is the sign of pi over 2? We got to be faster with that, guys. 1. 1 times negative 3. Okay. I'm picking easy things in between pi over 2 and pi. So for sine, I would pick 5 pi over 6. Because what is the sign of 5 pi over 6? Okay, so this is negative 3 halves. And then pi, what's the sign of pi? 0. Okay, real quick, let me plot those. You go left 3 down to pi over 2. Left 1.5 all the way around 5 pi over 6. And then 0 pi. So do you guys see how that would be the right side of your circle? That's what you get out of that interval. Okay. Woo! We made it, guys! The homework is the worksheet in your homework packet that says A2. Okay? Yeah, all right, guys, have a great weekend. Long weekend.